Hello guys, today we're going to take a look at this little module here, which comes again from IC Station. They just sent it in for us to review, and what it is a little radar module that senses the presence of a person or something moving, I suppose, in the range of the little radar here. So what we're going to do is just kind of talk through this little module today. So if we take a look at the back of our little module here, we can see this little wire sticking out, and that is our antenna. So what they've done there is cut the length of wire to the correct wavelength for the frequency of the little radio module in this. So it's supposed to be at 5.8 gigahertz. So a wavelength at 5.8 gigahertz is around 52 millimeters. So if we do a little measurement, we should be getting something, probably a half wavelength monopole, which would be, you can't see that in the camera, just give me a second. So if we get our calipers here and we measure the antenna, we should be about half a wavelength. No, it's a quarter wave monopole. It's about 15 millimeters, so it's in the region of quarter wavelength, I guess. So what they've made is a quarter wave monopole antenna on a little ground plane here, and I'd imagine that if you were to measure the radiation pattern of this, you would probably see like a donut shape that was kind of protruding forward. So there would be a kind of a null in the center directly on top of the antenna, and then the bulk of the radiation is probably focused around about going out like that kind of direction, if you know what I mean, and around in a circle, like a kind of a donut shape. And if you think about it, that is what you'd want if you had a little radar. Say if we had this in the middle of the room, you wouldn't need your energy being measured directly below the antenna, because you are unlikely to have an entrance unless you have a hatch into a basement or something below the antenna. You're not going to have an entrance point into the room beneath the antenna. You're likely to have it in any area around the antenna, I suppose. So that's where you want the most of your energy being sent. So if we take a look at the contacts here, we can see there's an L, N, C and E. So I'm pretty sure that that is live, neutral and earth. And what C is, I'm not sure, probably the signal back out that you would use to switch on your lights or something like that. Maybe switch a relay or something along those lines. But I am not going to show you how to hook this up to mains electricity. I think that's a very bad idea to be telling you how to do that, especially given the age of some of the viewers. I'd strongly advise against playing around with mains electricity if you can at all avoid it, and in this instance we can, because if we flick over and we have a look here, we'll take our components out of the way here, and hopefully my camera will focus a little better. So if we move our components out of the way here and we take a look at the circuit, we can see that in here we have a little bridge rectifier. So that would suggest that the first thing that our module is doing here, which would be obvious enough, is taking the mains electricity and converting it to DC. Then if we look at this component, it's a 5-volt regulator. So if we take the input here and the ground connection, take wires off them, we can just supply a DC voltage, maybe, I don't know, we'll say 12 volts or something, directly to that. It's an L8705, is it? Yeah, or 78L05 maybe is what it is. But anyway, it's just a very basic 5-volt regulator. So we'll just supply the DC directly to that regulator, and then hopefully we'll be able to get a signal. I'm guessing that we'll be able to get a signal out of this little LED output pin here, because I'd imagine that's an LED that lights up when something comes in range of our sensor here. So where are we going to find the easiest point to solder to? So our regulator here, we know it has to take a DC input, and we know that this is the ground and this lowest leg on this side is the input, and as well as that we have this capacitor here which is rated to 16 volts. So I'm hoping that if I test the connections with my multimeter, I'll be able to figure out, or I'll see that the positive of this is actually connected to the input voltage, and the ground will obviously be connected to ground anyway, but I have my multimeter set to check for continuity. You can hear the buzz. So let's go for the ground wire first, if I can. So there's ground, and we know this is ground. That's to be expected. Let's try the positive leg. It's very hard to do around the camera. Hitting every pin. Good. So looks like we can just solder directly to our capacitor legs here, because that'll be easy, because obviously the capacitor legs are quite long. So we'll just solder 2 wires to them, and then we'll be able to power it up. Well, in theory we'll be able to power it up. Maybe I'll just end up blowing up the board here or doing some damage, but we'll see what happens. Okay, I've added in a battery contactor here, so just positive and negative to the capacitor like we said, and on the little LED output thing I have connected these 2 wires. The green is connected to the ground and the yellow is connected to the positive. So let me bend this thing back in, whatever way that was, in there somehow. So stick our little antenna up that way, so we'll hopefully be radiating out the ways. I'm going to use this battery, but I'll check that it actually has power. Okay, so about 6 volts. That'd probably be okay. Might be a little low for the input voltage of the L8705, isn't that what we had? I think so. Let's plug it up and see what happens anyway. Plug it in and see what happens. So we immediately went up to 4.8 volts, which I guess would suggest that it's working. But other than that, not seeing much of anything happening. Although, in fairness, I don't really know what I should be expecting to see. Well, we're not seeing much happening, so maybe I'll hook it up to the oscilloscope and see does that shed any light on what's happening. Well, after playing around with it for a little while, I see there's 2 more holes here on the side of the board, and I think they're the output, because if I put the probe into one of them, you can see we have a train of pulses. Can you see that on the camera? Very hard to tell. Let me just zoom you guys in a wee bit. So you can see that train of pulses there, and if I move towards the sensor, you'll see it change. So that would suggest to me that what it's detecting is a movement rather than a change in the environment, I suppose. I suppose if you were to zoom in on them pulses, you'd probably see some subtle difference between when I'm not near the sensor and when I am. But just looking at it at the minute, it looks like it stays the same, but as you're moving you are distorting the pulses. So I guess that means that is probably the Doppler response, maybe, I'm not sure. Or well, that it's saying that you're changing the Doppler response. If you were monitoring this, you'd probably only want to see the change in you'd only be testing for a change. For example, if someone was moving in the room and you wanted the light on, you'd see changes all the time. But if, say, someone leaves the room, the pulses will stay the same then constantly for, let's say, you set for 10 minutes. So if the pulses don't change in 10 minutes, your sensor turns off the light. But even small movements is causing some change to the signal here all the time. So it looks like when I don't move, it kind of averages around 2.19 volts, and if I move, we distort it. But if we stay still again, even though we're in a different position, it goes back to around the 2.19 volts. So I guess that's probably what you're going to be trying to detect if you're hooking this up to a microcontroller. You're trying to detect that change in average voltage, I guess. I suppose we can use the multimeter to kind of see how you might use this. The multimeter kind of takes an average of a lot of measurements to give you your voltage reading on the screen there. So at the minute it's around about 2.5. So if you had your microcontroller averaging the voltage and you said that you expected it to be around 2.5 maybe, and or maybe you could have a average always changing. So let's say it's settled on 2.5 as an average, and then anytime it jumps out of a range of more than, we'll say, 10 millivolts from the kind of average voltage, that something is moving in the room, we'll say. So if I move towards it, you see it's jumping up and down. So there's a lot of voltage change when you move around. Maybe that's not a good example. It's kind of, I'm not really moving now and it's jumping all over the place. Well, I guess that's how you'd use that. You'd measure your pulses coming out of the output there, and if you've seen the width of the pulse changing drastically, you'd note that something was moving in the room. The little LED there, I guess then what that tells us is that all that LED is power indicator. So if there's power to the board, the little LED comes on. That's all that was telling us, or that's all it appeared to be telling us. So you need to measure the pulses coming out of the module to get it to work, I guess. I don't know what else I could really tell you about the module. I think that's as much as I'm able to figure out about it. If you want to get one of these yourself, you just head over to IC Station. They have this kind of 5.8 Doppler kind of radar thing in a couple of different electronics modules, so you can pick it up, and there's other frequencies, or you can get your ultrasonic rangefinders and all them other type of well, I suppose movement sensors. You can pick them all up there as well. They're not too expensive, all these modules. They're pretty handy for making robots, although this one, because, well, I don't know if you can really tell how close you are to the object using this, and you wouldn't be able to tell the direction because it's kind of omnidirectional. So I suppose this is not really for robots. It's probably for energy saving in the house or something. If someone's there, turn on the light. If they're not, turn it off, that kind of thing. So I guess that's all I can tell you about it. If you want one, head over to IC Station, and if you like the video, make sure and hit the like button, and if you have any comments or suggestions, let me know below the video. Maybe someone else knows how to analyse these pulse trains a little bit better. Let us know in the comments, and I think that's pretty much everything. So thanks very much for watching.